Hello, my name is Andrew Sherwood, and this is my ENME 351 lab number 4. Here's my Arduino code for the first example. As you can see, I've defined my serial monitor to initialize at the baud rate that matches the input to the VSA. I use a time start variable and millis in a while loop to create a delay that lasts the correct number of seconds each loop. And I have two analog reads. One of them is for the potentiometer to determine sampling frequency. The second analog read reads the N-scope signal and then prints that to the serial monitor to send to the VSA. Here are the screenshots from the VSA. At a signal of 75 Hz, the sampling frequencies of 100 Hz and 142 Hz are both aliasing, while the sampling frequencies of 200 Hz and 500 Hz are not aliasing. At a frequency of 100 Hz of the signal, again, 100 and 142 sampling frequencies are aliasing, 200 and 500 are not. At a signal frequency of 215 Hz, now the first three signal sampling frequencies are aliasing, and still 500 Hz is not. And finally, for a signal frequency of 300 Hz, all four different sampling frequencies are aliasing. Here are my calculations for the theoretical aliasing frequencies at each of the different sampling frequencies and signal frequencies. And here's the table. I'd just like to note at the sampling rate of 100 Hz and the signal frequency of 300 Hz, the aliasing frequency should be 0, but since my sampling rate was slightly higher than exactly 100 Hz, there was a little bit of error there that resulted in an aliasing frequency of 6.12 Hz rather than 0. This data makes sense because aliasing only occurs when the sampling frequency is less than 2 times the signal frequency. So for example, the 500 Hz sampling frequency only produces an aliasing frequency when sampling the 300 Hz signal. Likewise, the 200 Hz sampling frequency aliases at 215 and 300 Hz signals. The 142 Hz sampling frequency and the 100 Hz sampling frequency all alias at all the signal frequencies, 75, 100, 215, and 300. Here's my circuit now. For the square wave, I use the pulse function on the N-scope. And here it is on the VSA screen. On the left side, the frequency peaks here around 0 to 3, and then there's a little bit of noise going on to the rest of the graph there, just external noise that I can't control from the N-scope. Here's my circuit for the triangle wave now, and I'm using the analog input from the N-scope to create a triangle wave of 10 Hz. So here's the triangle wave going from about 0 to about 4.5 volts on the time domain. On the frequency domain, on the left side, we have at 0 frequency, we have an amplitude of about 2.5 volts, and that's the DC offset of the triangle wave. And then there's another peak around 10 Hz, and that is the frequency of the sine wave. Since again, this triangle wave is not aliasing, so we're going to see its true frequency on the frequency domain chart.